Good morning, afternoon, or evening to whoever see this. Uh, as of right now, I'm about to show whoever watches this about arithmetic sequences with explicit and recursive formulas, and with geometric sequences, explicit and recursive. And let's do it step by step. Let's do it. Okay, let's get started. So, as you can see, I got this wrong right here, so I will gladly fix my mistake. So we do not do anything to this n right here. This n is going to get distributed by the common difference. And with that being said, the nth term that we're looking for within the equation is, let's say somebody's looking for the 27th term of a certain number. So we plug in this big old number over here to the n. And so that's what we're looking for. And then this a1 over here, that's our first term. That's the term that we're supposed to do something with. So for example, we're going to do 2, -7, -16, let's see, and -28. All right, so off the rip, this is going to be our first term. Simple as that. Now, the common difference for this group of numbers would be -9, because 2 plus -9 equals -7. So our common difference, I do apologize for that, but the common difference is -9. So we are looking for the 10th term for this. So that's our first term. However, we're looking for the 10th term. So now we have what we need to start the equation. So a to the 10 low right there, you know what I'm saying, equals, it would be 2 plus, oh, my fault, my apologies. My apologies. So that'll be n minus 1, and then our common difference would be -9. So we would distribute the -9 over. So with that being said, so we're looking for a10 equals 2 plus -9n. So put that right there. And then minus, this would be, that would be 9. Negative times a negative is going to be a positive. So now we have all of that. Now we rearrange. So this goes over here. This goes over here. So they switch places. So it'd be a10 equals -9n plus 2 plus 9. All right. So 2 plus 9, that's 11. So right there, 11. Now, -9n plus 11. So this right here, this n now, we get to plug in the 10th term. So it would be -9 times 10 plus 11. So with all that being said, -9 times 10. I am so sorry. Just making sure I got my work right. So it would be -79. -79. And I will double check this just to make sure I got the right answer, because I ain't gonna lie, I am not sure if I wrote down a 7 or a 9. So, but this is the basic steps of looking for an explicit formula with an arithmetic sequence. Or arithmetic sequence with the explicit formula. My fault. Got that rearranged. All right, now we're talking about arithmetic sequences with a recursive formula. So for this, it is just simply. Ooh, I am so sorry. I am so sorry for that. But this will be talking about um terms adding constantly. So let's get started right away. So right now, let's do one example. Let's say this is not an arithmetic sequence. So this would be 2, and then oh, my fault. I am so sorry. 4, 7, 11. So 4, 7, 11. Now what we're looking for is a constant pattern of addition. So right here, 2 plus 2 is 4, right? However, 4 plus 2 does not equal 7. It was added by 3, it would equal 7. But we are looking for a constant. So this would be a no sequence. All right, just imagine that's a sequence. So this would be a sequence without any constant. We are looking for a number that we could add in different times, but in the same direction of a pattern. So we'll show a correct sequence that does have a constant. So let's do this. Oh, I apologize. And 1, 4, and 7, and then 10. So now 1 plus 3, that will equal 4. 4 plus 7, or 4 plus 7. 4 plus 3 equals 7. And then 7 plus 3 equals 10. So this is a constant. Constant number equals 3. So that's our constant number. So yes, it has a sequence. It has a sequence. So with that, we have that down. However, there's different ways on how there's different ways on how this is made as well. So let's start with 6. I apologize on that brief interruption. Now we will continue on to recursive formula. So 10. But there's also a different way on finding the constant number. So, and for the other terms. So this would be just another thing like this right here. So we are looking for the 3 terms after this. So 6, 10, 14, 18. Simple as that. But we have to look for the 3 more terms that also make it up, because that's what the question is asking. So this would be plus 4. 6 plus 4 is 10. Then 10 plus 4 is 14. And then 14 plus 4 is 18. And then 18 plus 4 would be 19, 20, 21, 22. 22. And then 22 plus 4 would be 26. And then 26 plus 4 would equal 30. So that will be our terms that the question was asking. 3 extra terms over here. So it would be 22, 26, 30. Now, that is done. However, now we need to find within an equation. So this would be our first one. So it would be n, an equals a n minus 1 plus 6, and then a1 equals 9. So, of course, we'll just draw it up like this, because this is how we are, how do you say? It is how we are doing it, I guess, yeah. Just making sure. Yep, okay. So, and then A. All right, so here's our terms. All right, so 1, 2, 3, and then 4. So first term is going to be 9. Because over here, a1 equals 9. So that's our first term. However, we are looking for the sixth term. So we'll just make that and then that. So for this, we have to add 9 6 times. So 9 plus 6, 15. 15 plus 6, 21. 21 plus 6, 27. And then so on and so forth. So these two spaces weren't needed because the original question was asking for the four terms coming from this equation. So breaking down this equation, our 6 is going to be our common difference with our 9, obviously made with the 1 right there, will be our starting term. So, common difference, starting term. This is a positive 6, so we add 6 into 9 4 times. So, plus 6, plus 6, plus 6. So, it all works out perfectly. Now, we are going to break it down to actually not break it down, we're actually going to make a recursive formula for the sequence that I'm about to put on. So it'll be negative 20, negative 15, negative 10, and negative 5. So with this being said, we have our numbers. So our starting term will be negative 20. So starting term. And our sequence that we're going in, our constant or common difference per se, would be positive 5. So, because of course, so positive 5, positive 5, positive 5. So, common difference equals positive 5. So, let's get started. Fn equals Fn minus 1 positive 5. With that, you make a little mark right there, and it would be F1, which is our term, equals negative 20. And that is how you make a recursive formula from the sequence that we were given. So, let's break it down. Our common difference would be positive 5. So it would be behind the parentheses at the end. And then you put a little mark right there just to signify, oh, hey, that's over. Now, F1, that's our first term. So our first term, like I stated in the beginning, was negative 20. And now we just made our equation. And that is it.